Welcome to Introduction to Bones for Orthopedic Beginners by Medi. This chapter will introduce you to bones and it will enable each and every learner to have a clear understanding of human skeleton and with a link for further development of skills in advanced learning. First and foremost, we'll begin from embryonic development of bony skeleton. Embryonic formation of bony skeleton begins at week 8 of embryonic development. Initially, embryonic skeleton is made up of fibrous tissues and cartilage, and the specific cartilage which forms the basic component of embryonic skeleton is hyaline cartilage. Basically, we have other forms of cartilages, which include the fibrocartilage and the elastic cartilage that are found elsewhere in the body. So mesoderm gives rise to embryonic mesenchymal cells that produce these membranes and cartilages that are gradually replaced by bony cells and then will develop into a mature bone tissue. So that's an overview of how embryonic skeletal begins. And much and in details, as you'll follow the discussion, you'll be able to find them right in this chapter. We have those bones that develop from fibrous cartilage are known as membranous bones, and the process is called intramembranous ossification. These are the bones that develop from fibrous membrane, and most of these bones are included the flat bones or the skull, which develop from fibrous membrane. Well, those bones that are formed by replacing hyaline cartilage is known as endochondral bone, and this process is called endochondral ossification. As you can consider this our structure, right here we have the reddish part, which is the formation of this the parietal bone being formed from intramembrane, from the membranes or the fibrous membranes, and this is the frontal bone also formed from the fibrous membrane. The translucent or the translucent areas are still the cartilages, and these other coverings are the tissues which will eventually grow into other parts of the body. So for the case of the wrist bones which are not yet formed, still replaced by cartilage, then will eventually grow into those wrist bones. In the case of the long bones, we have the humerus. The humerus is right here, still developing from cartilage. We also have the radius developing from the cartilage. Moving ahead, we'll check out on the bone cells, or the cells that form the organic component of bone. First of all, we have the osteoblast. These are bone-forming cells due to its ability to produce osteoids, the organic component of bone, and are composed primarily of type 1 collagen. So osteoblasts are bone-forming cells in general. Then osteoblasts line the surfaces of bone where they perform their functions of forming bone matrix and regulating the process of bone turnover by influencing also the osteoclast activity. So they line the surface of bone and they perform their function of forming bone matrix and regulating the process of bone turnover and by influencing osteoclast activity. They are produced by mitosis and differentiation of osteogenic cells, which are the osteoprogenitors. So the production of osteoblast is by mitosis of the osteogenitor cells. Osteoclasts are the cells population responsible for the bone resorption, and that is basic for bone remodeling. Their function basically is by digesting bone matrix, where osteoblasts have deposit the same matrix. So, and histologically, we're told that osteoclasts are multinucleated cells. So, because of their major role in digesting bone matrix, they have to be stronger. Osteoclasts are derived from pluripotent hematopoietic stem cell of macrophage or monocyte lineage. And we can consider from our structures here, we have osteoprogenitor cell developing into osteoblast, which is this. Then the osteoblast is being formed. Eventually, we have the osteocyte, which maintains the bone tissue. So the osteoblast, after being deposited, it's then trapped into some pocket like tissues, then will eventually grow into osteocyte. And finally, here we have the third bone cell, which is osteoclast, which is its function basically being the destruction of bone matrix. Yeah. Osteocyte, the mature bone cell formed from osteoblast that have become trapped in the matrix being deposited. The osteocyte, which is just seen right here. Yeah, this is the osteocyte. Osteoid, the mineralized bone matrix composed of proteoglycans, glycoprotein, and collagen. This is just an additional information of more about what osteoblast secretes. So the osteoid is the mineralized bone matrix composed of proteoglycans, glycoprotein, and collagen. Okay, we'll move ahead to inorganic component of bone, which is mainly formed by calcium phosphate donated as hydroxyapatite ions. So the calcium phosphate forms 65% of bone mass and provides for its general hardness with resistant compression. And in conclusion, bone is considered to be as 50% compression strength of steel with 100% tension strength of steel. That's just a comparison that tension and compression strength of steel. This mineral salt surrounds the collagen fiber in the extracellular matrix. Yeah, they surround the collagen fiber. Then this disease, the disease called osteogenesis imperfecta. This is due to defective collagen formation, which leads to bone being soft and brittle. So, and that's why we're told crystallization alone will make bone brittle, and thus the bone is subjected to diseases. And the one which I've just stated is osteogenesis imperfecta. We'll move ahead to types of bonds and the classification of bonds by shapes, which is the first discussion. So we have long bonds. Long bonds, these are the longer bonds that they are wide, they are longer than they are wide. Long bones consist of diaphysis, which is the shaft, and epiphysis, which is the end of long bones. We'll discuss much down there as we move ahead. They include bones of the tibia, humerus, and femur. Also, we have other bones like clavicle. Those are just but other examples. You'll have to review them later. So the next we have short bones. They are more of cube shaped. These include bones of the wrist and ankle. And right there we have the short bone, which is the carpal bone, which is one of the short bones. Next we have flat bones. Flat bones are thin, flattened, and a bit curved. And the examples are sternum and most skull bones. And for our case, we have there the frontal bone, which is one of the flat bone. As stated earlier on, they are formed from fibrous membranes. Irregular bones. They are bones with undefined shapes. These are vertebrae and hip bones. They have undefined shapes. They are called or considered as irregular bones. One of the examples there posted is the bone of the vertebra. Sesamoid bone. A sesamoid bone is a roughly triangular shaped bone, and the example is the patella, which also forms within the tendon sheath. So the patella is one of the example of sesamoid bone. So moving ahead to the structure of bone, we have the basic structure of bone. what does the bone contain and its basic nature. We have the periosteum. A periosteum is a double-layered membrane. The outer layer is tough and fibrous with dense, irregular connective tissue, which protects the bone underneath. Yeah, so the periosteum is a double-layered membrane that covers the bone its all length. So its outer layer is tough and fibrous, while its inner layer is dense, irregular, with connective tissue. So the inner layer contains osteoblast and osteoclast. Yeah, these are bone-forming cell and bones that are these are the bone-forming cells and the cells that are responsible for breakdown of bone, respectively. Periosteum is secured. Periosteum is securing the bone by perforating fiber and covers the whole length of bone, but with the exception within joint cavities where it is replaced by the hyaline cartilage. So within the joint cavities, we have the hyaline cartilage covering the end of long bones. We're told that ligaments and tendons can anchor the periosteum. So the periosteum provides the basic surface where the ligaments and tendon can anchor, and especially on the along its length here. Thank you. We have endosteum. Endosteum, just like periosteum, but this a little bit more of internal surface. So it's a delicate membrane of reticular lining the internal surfaces of a bone. So it lines the canal of compact bone and covers the trabeculae of spongy bone. So endosteum is now the inner covering. And they also contain, or they also have these bone forming and bone destroying cells, the osteoblast and the osteoclast. Right away, we'll have to check on the bone texture. The first one being compact bone. And the compact bone, we have their dense outer layer of bone, while spongy bone are the internal compact bone with honeycomb-like appearance, or also known as cancellar bone. So the cancellous bone are the same as applied to spongy bone. So they are compact on outer surface, well, on their inside they look like honeycomb. They're just like honeycomb. How they're detailed down there. So microscopic structure of compact bone, we have some parts of this compact bone. And first of all, we begin with the Haversian system or osteum. So osteum, they are parallel tube-shaped units forming the structural unit of a compact bone. So these parallel tube-shaped units are they are known as the osteum, and they form the structural unit of compact bone. The central canal, this is a canal or a channel within osteum containing blood vessels and nerves. The central canal, there are channels within osteons which contain blood vessels and nerves. Perforating canal, channels lying at right angle to the central canal connecting blood and nerve supply of the periosteum to that of the Haversian. So these are channels lying at right angle to the central canal. So they are linked to each other. From this diagram, the two just here, we have the basic structure of compact bone beginning from here to this end. We have the perforating canal, the blood vessels or neurovascular elements. We have the central canal. We have the osteon or the Haversian system. We have the concentric lamella, which we will be discussing down below there. We have the canaliculi, which we'll be talking right away. We have the periosteum, outer layer, and the inner osteogenic layer. We also have the periosteal arteries. Here's my arrow. We have the periosteal arteries right away. We can find them there. And also we have the canalicular osteocyte inside the lacunae, osteocyte, within the lacunae, which we had stated earlier on. Osteocytes are mature bone cell. This structure has been obtained from a long bone, that is femur. So the same structure is just here, but more advanced. We have the osteon, the cylindrical shaped tube, which means it has the canal or the Haversian canals. We have the lamellae, we have the canaliculi, the osteon, periosteum, the covering of the bone, Volkmann's canal, sorry, which is also the uh, the canal that branches to the main canal. Circumferential lamellae have the osteon of the compact bone, and we have the compact bone itself. Lamellae, the series of cylindrical plates of bone, mainly made of collagen, arranged around each central canal. The series of cylindrical plates, which is this, the series of cylindrical plates. This is the cylindrical plates arranged forming the osteon. So that is the lamellae. So we have lacunae, small cavities in bone that contain osteocyte. The one which I shown you earlier. The lacunae, these are the stuff here. This is another one. The other one is here. These, they contain osteocyte. We have osteocyte, the mature bone cell, canaliculi, series of tiny hair-like canal channels that connect lacunae to each other and to the central canal. Series of tiny hair-like canal or channels that connect lacunae to each other and the central canal. Interstitial lamellae lie between osteon, and they are considered as the remnants of older system partially broken down during remodeling or growth of bone. So the interstitial lamellae, I'll just have to show you them because that is what just brought me here. This is now the interstitial lamellae. Yeah. We'll move ahead to the structure of the microscopic structure of cancellous or spongy bone. Spongy bone, they are not made of osteons, those tube-shaped canals, so they're not made of them. They're made of trabecula, which consist of few lamellae and osteocytes interconnected by canaliculi. They're made of trabeculae, which consist of few lamellae and osteocytes interconnected by canaliculi. The spaces between the trabeculae contain the red bone marrow. So I'm going to show you that, and this is the case. This is the trabeculae, which also have the osteocytes. Yeah, so bone forming cells produced by endosteum and the periosteum also there. They form the basic organic component of this spongy bone. And this here is a marrow space containing the red bone marrow as stated. That's the basic structure of cancellous bone or spongy bone. It's not much advanced as the